A map is a two-dimensional or flat-scale model of the Earth's surface, or at least a portion of it. The science of map making is called cartography. And we use maps as two different main purposes. One is a reference tool to identify where something is, whether it's absolute or a relative location. And we also use them as a communication tool to show the distribution of human activities or the distribution of physical features across a landscape. So one of the first maps we'll look at, one of the first ones listed in your book, is a topographic map. A topographic map shows contour lines of elevation, so it shows you how high or low the land level is. It shows you different urban and vegetation surfaces. And it shows you natural landscape features. So it's very much like a physical map, which is what you would have called a similar map probably when you were younger. We also have thematic maps, and thematic maps don't focus on landforms or features, or even necessarily where something is an absolute location. It focuses on different topics, so you're not going to use one to find your way around. So this one shows you the most popular food raised per state. So this one is like a pictograph map. Here's another pictograph map, shows you what kind of soda is purchased most commonly in each state. And this one is another map, thematically, where it's showing you what people call different soft drinks across the country. We also have thematic maps that show you differences in kind. And in this case, they're just coloring in the states that voted for Bush in red and the states that had a higher number of voters for Al Gore. This would have been the 2000 election. Here's another one that shows you the distribution of different religions across the world. Same thing, a thematic map that shows you differences in kind. If we're looking at differences in value, we're looking at a choropleth map. The choropleth map is going to be different shades of the same color usually. And they're going to show you the percentage of something and how it varies. So here you can see the percentage of economy that's involved in primary economic activities, things like agriculture, forestry, and mining. So you can see like North America here, the U.S. does not have most of its economic activity in these primary sector activities, but many countries in North Africa and Sub-Saharan Africa, many countries in parts of Asia, they do. Same thing, that map we looked at earlier this year about rates of cancer in the United States, within Maryland, and then within Baltimore, that was a choropleth map. It shows the shading of regions to show degrees of a topic. We also have cartogram maps. And a cartogram map, the map is going to adjust the size of a country or the state or the county to show the relevance of a topic. So this is one that is adjusted to show the population size. I have one like this that's on a grid, so you can kind of see the pattern easier hanging up on the wall in the classroom. So a cartogram means that if you have more of something, it's going to be bigger on a map. And again, this is based on population size. Here is a map of the U.S. where each state is sized according to the number of votes it had in the Electoral College. So same election as the map we looked at earlier, the Gore versus Bush, but now each state is made bigger or smaller based on the number of votes it had. So as you can see, some states have more votes. They carry more weight within the Electoral College, and so they're weighted bigger here. Another thematic map would be the dot density map, where you put dots in to track something. So this is tobacco agriculture in 2002, and the more dots there are in an area, the more that phenomenon occurs. So in this case, it could be tobacco agriculture. It could be the number of a type of restaurants. It could be population. It could be availability of fresh water. It could be really anything. Just when you see more dots, you have a higher density. And then, of course, there's the traditional political map where you see the governmental boundaries of countries, states, and other counties. One last one mentioned in your review book is isolenes. These are when you have different contour lines. And this is usually just going to show elevations, although it can sometimes show like temperature gradients. Just as a review, large scale and small scale. Here's a small scale map, right? Because it's zoomed out more. And then here we've zoomed in, and now it's large scale. And so now we talk about scale, we can talk a little bit about map scale. So we've been talking about the idea of scale as a level of analysis. And these terms, large scale and small scale, kind of come right from the idea of scale on a map, the number scale. And so you can see the map scale represented in 3 different ways. As a ratio or a fraction, so 1 to 200 to 24,000. So every 1 inch on the map is equal to 24,000 miles. You might see it written, so it would say 1 inch equals 1 mile. Or you might see the graphic scale, and that when they give you a line, and they will say like, and it's marked on there, this far equals 10 miles. And so you'll see those graphic scales on maps a lot. So when you look at the term large scale or small scale, if you take the mathematical map scale and divide it, small scale means that 1 into 10 million, that's a tiny, tiny number. This is a small scale map. When you divide 1 to 10,000, that's a bigger number. So this is why it's a large scale map. So as you change that mathematical scale, that's where we get the terms small scale and large scale. So you can just look at what that scale would be. 1 out of 10 million is smaller than 1 out of 10,000. This is the largest scale, so that final number. We also have to talk about projections in maps. So when we transfer locations on the Earth's surface to a flat map, we call that a projection. So the Earth is round, our globes are round, and when you take something that's round and you put it on a flat piece of paper, it distorts. We have 4 main types of distortion. 1, you can change the shape of an area to try to make that round image flat. You can change the distance between points, making it smaller or larger. You can change the relative size of areas, or you can change the direction between points. So here's one of the most popular projections. It's called the Mercator projection. Here's an interrupted projection called the Good-Hamiltonian. And then here's the Robinson projection. So when we look at these maps, what is the main difference about them is that they have all chosen different types of distortions. So the Mercator projection is heavily distorted the further you are away from the poles. So this one is great for navigation because the distance between these landforms doesn't change. So if you were trying to navigate across the ocean, this is a great map. But what is distorted is the size of Antarctica and the size of Greenland. So these areas here, Canada, Greenland, Russia, then Antarctica in the south, they're all bigger than they should be. So the further you get away from the equator, the more heavily distorted they are. And they're distorted both in shape and size. The Robinson projection is very pretty. It has low levels of distortion all over the map, but it has many types of distortion. So it has distance distortion, distance, a little bit of shape, and a little bit of the landmass size. So I think it's one of the most attractive maps, but it's not always the most useful. This here is an equal area conic projection. This means that you are seeing the world and everything is the right size. It's useful to demographers, but it distorts the shapes of the continents, so it's not always the most useful. Again, here we are back to getting to the shape preserve. These are called conformal projections, and we'll work with those in class. And then ones to preserve distance. And we'll go over these different types of projections in class, so don't worry about them too much right now. This is about it. We're going to go over different projections in class for a lab. So I'll see you in class.